Okay, so triangles. Something that you should definitely know about triangles is that if you draw just a kind of generic looking triangle that doesn't have any special properties to it, there are some interesting things about this. You can see this is the shortest side of them all, right? You see the other two sides are longer. If you look at the angles, isn't this angle the shortest angle? Right there? So, it turns out that's always true about triangles. That the smallest angle, which is only this big, is opposite from the shortest side of all the sides. So which one is the longest side? Well, I would say this one down here is the longest. This one, I'm going to label longest side. Now, of all three of these angles, which one seems to be the widest? Well, just looking at it, to me it looks like that one's the widest. That is the biggest angle. Okay, so this rule is true just like the short to short. The long to long rule is also true about all triangles. That the longest side is always going to be across from the longest angle, and the shortest side is always going to be across from the shortest angle. Okay, now sometimes they give us triangles that are a little less clear than the first few examples that we did. Okay, those are called ambiguous. When something's ambiguous, you're not really sure exactly how to define it or what it is. So, let's first just look at what these angles are. This is 57 degrees, angle A. Side A is 33, that's down here. Side B is 26. Okay. Now, this diagram is not going to be perfect, meaning that the proportion of all of the sides are not going to make a whole lot of proportional sense. So like, for example, here, see this angle right here? Is that a 100-degree angle? No, because it would be bigger than 90, right? So the triangles that I've drawn are very generic. They're only supposed to be used as labeling devices. They're not actually supposed to look like the triangles that we're drawing, okay? So, keep that in mind as we look at this triangle. This actually does look like about 57 degrees, but that doesn't necessarily mean that these are going to be the same, okay? All right. So what angle could we find first? Well, using the law of sines, we could find B. Because we have a good pair, we could use this A over sine A. And we could use these two, B over sine B, to find corner B. All you need is 3 out of 4 of these number values to use this equation. So, A is 33, sine of 57 equals 26 over the sine of angle B. All right, now the calculations of this one are going to be a little bit different. First, I'm going to cross multiply, so I'm going to multiply this way, so I get 33 times the sine of B. Then I multiply this way, which gives me 26 times the sine of 57 degrees. And then I just divide both sides by 33. So I have that the sine of B equals 26 times the sine of 57 degrees, all divided by 33. All right, so I'm going to go ahead and do that on my calculator. So 26 times the sine of 57 degrees, enter, divide that answer by 33, and there we go. We have 0.66077. So the sine of B equals, okay, so that's 0.66077, and now we have to find angle B by using the inverse button. So the inverse would be this one right here. Now what's going to happen is that the inverse is only going to give us one possible answer. And it says that the angle is 41.36 degrees. Well, that may or may not be the case, because this may be a small angle, 41.36 degrees, or it could be an angle that's in the second quadrant, because when we take the sine of an angle and we get a positive answer, isn't it true that this could be true, that sine is like y, right? So if sine is like y, then that could be positive in quadrants 1 or 2. Okay, so the calculator just gave us the first quadrant angle, 41.36 degrees. That's how far we are away from the x-axis. However, we could also have an angle B that's an obtuse angle, bigger than 90 degrees. And on this side, it's still, again, 41.36 degrees away from the x-axis. So if this is 180, the other possible position for what angle B could be would be 180 minus 41.36, which is 138.64 degrees. So I'm going to now assume that if that is the case, if this is an option for angle B, well, and this is angle A, is that possible? Can angle B be 138.64 degrees if angle A is 57? No. The reason for that is that these two, when you add them up, are larger than 180 degrees, which means that angle C would be either 0 or negative. So this, while we had to actually consider its possibility, is not possible when you look at the fact that all three angles have to add up to 180. So I'm going to toss that possibility out, and the only angle B that I'm going to accept as an answer is 41.36 degrees. Now we're supposed to round off to the nearest tenths place, so here we go, 41.4 degrees. Make them happy. So that's how you find the first step. The rest of this is all just adding these three up to be 180 to find angle C, and then using your sine values, sine ratios to find side C. And that's how you do that one.